In this video, I'll be going through how to make predictions using your least squares regression equation. So by this stage, if you don't know how to create a least squares regression equation from data, or how to read a least squares regression equation, I suggest that you go back and watch the other videos or get in touch with your teacher. Okay, so we all know what a least squares regression line looks like. We can either be given this in the equation, so our RV or our response variable is given by a plus bx times your explanatory variable. Remember that a is your intercept and b is your slope of the line. And remember that the least squares regression line, we get a scatter plot. Your least squares regression line, your calculator does beautifully for you. Takes out all the guesswork based on reducing the distance between each of the dots and the line, so it adjusts it perfectly and gets it really, really accurate. So you don't have to guess or do a line of best fit or anything. Your calculator does a really super job of doing that. So anyway, so the least squares regression line given in this form is the line that you will see appear on your scatter plot. And the awesome thing about that and data and this whole topic is this little guy can allow you to make predictions of the general gist of what you're looking at. So you may be looking at, so for example, where this is used in everyday life, if for example, is if you had a shop and you were looking at your sales over time, so your sales over time, you could map out all your sales for every month over several years, and you could see that you're generally improving. So your profits are going up, kind of thing. So that's a really good thing, and you can put in strategies in place to improve it or whatever. So if just say I wanted to if I was looking at my years 2016 to 2019 and I wanted to make a prediction of 2018, say in May or whatever, I could use my least squares regression equation that I've got from using my raw data, and it will give me a prediction of the approximate profit I should have made for that particular time. And by visually how to see that, it would be looking at this point on your least squares regression line. When we use the equation though, we get a much more accurate depiction of what that is. So if I've made a prediction, if I'm going to use the example of my sales over time, if I've made a prediction within the range of the years that I've looked at, I'm going to be able to comfortably get a prediction that I can see is pretty close to what I actually got, or within the range of what I actually got, because I'm predicting, if I use my little pointer, because I'm predicting within the range of data that I already have. So it's safe to say that that prediction will be fairly accurate. It's also reliable, all right, because we do have data within, I have data within 2018, and I can comfortably say that's a good prediction. So we call that interpolation because it's in the range of the data that I'm predicting, that I have, so therefore it's a reliable prediction. Okay, so just keep that in mind. So interpolation inside the range of the data is reliable. However, if I say if I've got a shop and I'm selling whatever, I'm looking at my profits, I'm going to assume, this is the great thing about statistics, I'm going to assume because my data has I've continued to improve my business, and I'm going to assume that my data continues on this fabulous pattern up this way, and I'm going to make a prediction for 2020. All right, and I'm going to make this prediction when it's 2019 or something. I'm just going to get my figures in line, and I'm going to make a prediction for 2020 and guess that it's going to continue on the same thing, and I'm going to get X amount of profit. Now, I don't have data for 2020. I'm going to assume that I'm going to continue to make all this money and improve my business, and it's going to predict up at a value like this, and it's going to be all very good. However, I don't have data for 2020. It's outside the range of my data. This is not reliable because I don't have data within this time frame. All right, I can assume that my profits will continue to go up in the same fashion as it has, but I can't. It's not reliable because I don't have actual data for this year. Case and point with 2020. I'm sure a lot of people may have made predictions about their profits for 2020, and then no one knew that there would be a global pandemic. So while I can make predictions in the future, this is called forecasting. It's very common in business and finance and all that sort of stuff. It's not reliable because I don't have actual data within that time frame, and we call this extrapolation because we're extrapolating it out of data that we already have. So we're making a forecast. It's not always reliable. All right, so interpolation, inside the data, reliable. Extrapolation, outside the data, not reliable. All right, let's have a look at an example and we can go from there. All right, so the equation of the regression line that enables the price of a second-hand car to be predicted from its age is given by price is equal to 35,100 minus 3940 times the age of the car. Use this equation to predict the price of a car that is 5.5 years old. So whenever you're making a prediction, I strongly urge you to do these steps just while you're getting used to stuff. First step, write down the rules. So I've got price is equal to 35,100 minus 3,940 minus the age. Then you need to ask yourself, what part of the equation do I have? Like, what variable do I have? So the question says I have a car that is 5.5 years old. So I've got the age. So I've got this part here. So the second step is you're going to sub in what you've got. So just following the same rule, and then that was times. So times 5.5. And whenever you're finding the RV, it's really simple. You just put that part in your calculator. So in the main part of your calculator, I've full on changed the number of the A there. So through 35,100 minus 3,940 times 5.5. And that will give you this value here of $13,430 for when the car is 5.5. All right, so after 5.5 years of age, we've had a price decrease, or the price of the car is expected to decrease to $13,430. A great way to check if you have been given the graph in your textbook and the least squares regression line over the top is you can use the line to see if your prediction is correct. So for example, 5.5 is here on the age scale. I go up to the line and across, and that's about, I'd say where that is about 13,000, which is roughly what I got there. Using the actual visual of the line is good for a check, but I would highly recommend that you don't rely on this to get your prediction. You should always use the equation, because we've got like decimals in here and quite large numbers, so you'll get a much more accurate number using the equation. All right, so if I'm predicting for 5.5, this visually can see my first ages of the car was 1, and the later car that I had was 8 years old. So if I'm making a prediction of 5.5, that's clearly within the range of my data. So we say that this is interpolation because it's within the range of the data. So it's interpolation, and we say that this is reliable because I have data around these values, and it's just a much more reliable prediction because I can see what's happening. However, if I was to make a prediction of a car that is 8.8 years old, I would do the same thing. I can still use my equation because I'm going to assume that the prices of the car continue after 8 years in the same path. So I've got my equation here. I'm subbing in 8.8 for age, and I get a price of $4,388. Now, if I take you back over to our graph here, so remember the last point we had, the last age was 8 years. So if I've got a car that is 8.8, that is outside the range of my data. So I can't, so that is an extrapolation prediction, and it is not reliable because I don't know what happens after that 8 years. Maybe it gets to vintage age and they start going up. Who knows? I have no idea because I don't have data beyond 8 years. All right. While you can still make a prediction outside the range of your data, it's an unreliable prediction. All right. Okay, let's have a go at one on our own and see how we go. So the equation relating to the weights and heights of groups of students that range from 163 to 190 centimetres. This thing is very fiddly. My cat is going mental. Is given by weight is equal to minus 40 plus 0.6 times the height. Use this equation to predict the weight in kilograms of a student with the following heights. Are you interpolating or extrapolating? Okay, so first step. Let's do A first. First step, write down the equation. So weight is equal to negative 40 plus 0.6 times the height. Next step is you decide what variable do you have? Like what information do you have? So 170 centimeters is referring to the height. So I have to sub in this part into the equation. So I'm subbing in for height. So 140 plus 0.6 times, where did I get 140? I said minus 40, sorry, minus 40 plus 0.6 times 170. Okay, and then you just plug that into your calculator. So it's minus 40 plus 0.6 times 170. Enter. So that student would be 62 kilos. So 62 kilograms. Okay, so if I'm making a prediction for 170 and my range of heights is 163 to 190, so anything within that range of the data is interpolation. So 170 is clearly within that, so this is an interpolation. Therefore, it is reliable. Okay, it's a reliable prediction. How about 65? Let's have a look at this. So again, write down the equation. 6 times height, and then 65 centimeters, so that clearly is a height, so it goes in this section here as well. So 0.6 times 65, and then I just go to my calculator and do the same thing. So with these ones where you're making predictions, you can just go up here and change that, or you can highlight with your stylus and drop and drag, and it will just copy the equation, whatever floats your boat. 65, I think it was. 65 minus 1 kilos. Is that even possible? I don't think so. So minus 1 kilos. If you are obviously 65 centimeters, we don't have a student who is 65 centimeters within this data set, so this is clearly extrapolation. It's unreliable, and it's also a little bit silly. You can't have negative weight. So sometimes when you're making an extrapolation, it will come out to be a little bit odd because it's outside the range of the data. All right, so if that happens, don't stress. You might just have to interpret that and just say it's not reliable because it's extrapolation. Totally fine. Now, I'm going to throw in a part C here for where we have a weight of 55 kilograms. All right, so once again, weight is equal to negative 40 plus 0.6 times the height. Now this time I have been given the weight of 55 kilograms and I want to predict the height. So I have this part here now. I have 55 kilograms minus 40 plus 0.6 times the height. And I'm solving for my unknown here, which is the height. So these ones here before, I was solving for weight. Now I have the weight and I'm solving for height. So you're going to use your calculator here to help you. Whenever you don't have a variable within your equation, you're going to use your calculator to do all the hard work for you. And all my students will know what I'm talking about because I yell at them all the time about this on your calculator. So you're going to use solve in your calculator. So I'll get rid of that so you know what I'm talking about. So in the main page again, bring up your keyboard. In your Maths 1 keyboard is solve, this one here. So solve. And you plug in your equation as you see it. So we know the weight was 55, and then the equation said negative 40 plus 0.6 times. Now I didn't have the height here. So big tip, whatever you're solving for, if you're using the solve function, whatever the variable is that you're solving for, just let it equal x, because your calculator's programmed to find x, and then you don't have to let it know what variable you're finding, because that gets really old and we don't have time for that. So just let it equal x, and you know that represents height in this example. You don't have to close your brackets or anything like that. If you are using a TI, you do have to close your brackets, and you always have to comma with whatever variable you are using. So, and then I just press execute, and then it's going to make a prediction for the height. So 158.3333333. So that is roughly, to the nearest centimetre, let's say 158 centimeters. Again, 55 kilograms, or sorry, no, 158 centimeters is not within this range of the heights. So this is again extrapolation. And it's unreliable. Hopefully this has helped clear up making predictions using your least squares regression equation. This was really important for year 12 as well. It's not a difficult thing to do once you get your head around it. Just practice and use your calculator. It is your friend. And it will be really useful if you go off and study statistics. It's also really useful to interpret graphs and just like graphs that are used on the news and things like that, and just have an understanding of how data can be manipulated and used to display information. Hopefully this has helped, and it will put you in a good position to complete your exercises. Thanks.